Next up, we're going to hear about tackling circularity for polyolefins and base chemicals with the ABC approach. What's the ABC approach, I hear you cry? And to tell you all about it, from Borouge International, Annika Huomo. Annika.
So, thank you. So, this year I got the whole stage for myself. So I'm Annika Huomo from Borouge International, and my mission is to support our customers and value chain partners explaining their customers what is the difference, what is the value they get when they are taking, instead of a traditional fossil, some circular alternatives. And for some of you where Borouge International doesn't resonate, maybe you recognize a bit better the Borealis logo. And some of you might have read that during this spring, in end of March, Borealis and Borouge joined together, and also Nova Chemicals joined to the family, and the new name of the family is Borouge International. Together, we are supplying worldwide polyolefin products, but also base chemicals. And in the past, the Borealis has been on a driving seat for the circularity, and also in the future, circularity will be driven from Europe. So nothing has changed on our targets. We just become a bit more bigger and more ambitious. And so actually recapping a bit what we do. So we offer the polyolefin products, so the granulates you see in a picture below, but also besides this, we supply base chemicals like phenylacetone, butadiene. And with all these applications, the traditional fossil version can be replaced with the circular alternatives via mass balance. We deliver materials worldwide. Together, most of the circular products are coming from the European assets, but basically we can supply within the same name anywhere in the worldwide. We are ISCC certified with all our locations in Europe, and also in the US, and also in Asia. Borouge in the past was selling our products produced in Europe, and now with the name Borouge International. As a little bit kind of also explaining who we are and the aspect of circularity, we were the first partner in when Allen MacArthur Foundation was starting up. And that time we were also the first polyolefin producer signing the statement. And we are proud of the cooperation that we have still with Ellen MacArthur Foundation, and we are also operating with several different other projects worldwide linked to the circularity in all the aspects of the ABC plus something else, which I will explain a bit later. Also, we are EcoVadis ranked, I think this year the gold medal is what we have reached. And actually then, coming a bit closer, what we do in concrete. So we operate in basically any polyolefin application you can imagine. You most likely will find something from our portfolio. And as we operate with mass balance, we can offer in any applications as a drop-in solution. So basically, you can start with circularity already today. Consumer products, meaning packaging, different type of application we see in everyday life. This was the first one where everything started, so to say. And of course, the pressure with the European PPWR coming, the pressure is high. But actually what we see today is more and more energy, which means wire and cable application, pipe in infrastructure, but also mobility and advanced products, which is covering then anything from the textiles to the healthcare to special polymers. We see these growing, especially in the energy sector. The materials, there's a kind of compostability, short-term aspect is not something that is the driver, but really that how can you lower the carbon footprint of the product? Because also these products, in one way, they are operating as a carbon storage, even though it's not recognized today in the European Union and association level. But if you have a cable that is lying in the ground or under the sea for 100 years, it's, first of all, you don't want to be compostable because you don't want to it to disappear while it's there. And also, it will be quite long stored there. So in one way, also the carbon is staying out from the atmosphere quite some time. But then coming to the ABC. So I mean, I think this is not the audience that I need to convince that we really should start having a circularity instead of as a burden and a regulation, but really to first of all have it as a kind of advanced way to differentiate, but also as asset. I mean, looking at our European aspect, first of all, C, coming from the chemical recycling. I think we don't have too much oil available in Europe, but we have a lot of plastic waste. Let's take that and use it. Let's not dump it anywhere. Let's take it back to the process and keep it in a loop. B, we have a lot of biomass. We have a lot of agriculture. Let's use the part that we don't eat. Let's take the waste streams from the restaurants for the cooking oil. I mean, let's use it. Also A, atmosphere. I mean, carbon, there's plenty of carbon around us. Let's not let it flow to the air from the chimneys, but let's collect it and let's use it. Let's not put it to the ground because, I mean, hiding problems, that's not usually kind of a good way to solve things, but let's take that to the use and replace the fossil with it. This is a picture that I like to show in every presentation, and this is the first time with the new colors, but still the content is the same. So this is our kind of ideal future outlook, where basically fossil is not needed. We have everything as a kind of closed loop, and then the kind of the fresh blood, the fresh energy is then coming from atmosphere or from the bio-based. And let's see, I think I don't have a pointer, but if you look like the starting point, so first of all, everything starts from designing the material. And that's where Borealis took already 10 years ago, 10 codes of conduct. So basically the aspects you need to consider when designing a new polymer. So that in order that it's easy to recycle, but also it will not, of course, the safety is key in everything that we do. And besides the safety in our customers' production, in today's world, it's important to also consider the impacts when it's recycled. And often, I mean, the typical example from the schools, Coca-Cola and Mentos. I mean, perfectly safe separately, but if you combine them, yeah. So this is the same thing also we can't, of course, prevent everything, but less chemicals you have in the polymers, better, from the recycling point also. And where can be reused, that should be always, of course, considered in the application where we can do it. If some of you were participating in a Eurovision Song Contest in Vienna, there were some cups that actually were made from chemically recycled, sponsored by us, and they were kind of in a reuse circle. And this is a kind of typical example. You go to the festivals, you have the cups that are collected. First of all, they stay much better in the shape, so you can actually finish your drink with those. And the second, they can be reused several times. There has been several testings in also like in the fast food chains that if you have a packaging, how many times it needs to reused before it's actually kind of paying off. These kind of measures, there has been done a lot. In some cases it's working better, some cases it's not. Because of course also if you have a business case that you need to reuse this cup for 100 times and you use only 30, then maybe actually the single-use plastic would be, in total picture, more environmental. So that comes to the reuse. Then in the bottom, you have the mechanical recycling. So after everything is collected, sorted, and first of all, the sorting is very important in the recycling, to have a pure feedstock for mechanical recycling. So we don't talk about waste anymore, we talk about feedstock. And here, there comes a kind of first turning point. What can be mechanically recycled should be always mechanically recycled, and only then the chemical recycling. Of course, also with chemical recycling, it's not a kind of magic box where you just put anything. It's a sensitive. And if you're following the news, chemical recycling industry in Europe is getting hit by badly about the kind of delayed regulation, but also the technology is not really walking the park. Several fires, several bankruptcies, but it's something that we need to continue in this direction. And OMV, one of our owners, having a real technology and operational plants in Svehat in Austria, has been already working since 2009. So it's not something, basically, if we want to have the capacity to support our packaging, PPWR type of regulations in Europe, we need to have the capacity and it needs to start now. Coming to then to the next steps, so after the chemical recycling is supplying the big part of like in the RCI picture we saw yesterday in the IFF presentation, the rest, the fill-up needs to come from B, biomass, and then from the atmospheric carbon. Atmospheric carbon is really in the starting phase, but bio-based is already there. And there's plenty of options. And what is important here in the bio-based, because sustainability also always needs to be kind of considered that it is also in the long term sustainable. So we cannot dry out one source, but we need a combination of multiple sources. And it's also something that we have in our portfolio today, different type of feedstocks that we can offer in a kind of same platform of bio-based. Here, a few examples how it's in action. Atmospheric carbon, this is still super niche, but it's starting. And the train it's really, I mean, there's not too many wagons, but it's moving. And here we are working, because maybe coming back one step, so we work with the ABC approach, meaning that all the feedstock types are in the drop-in solutions are then the kind of bio-based chemical recycling or the atmospheric carbon. And here we need a close cooperation with our suppliers. Like for example, with atmospheric carbon, we work with our supplier Infinium, who's having the first commercial scale plant worldwide, producing carbon capture, and then we get it as a form of e-naphtha. It's not also totally walk in a park technology. They are developing, they have a nice interesting scale up plan, but the volumes are still small. But that's why it's also still interesting for some special applications where the volumes are not too big. I mean, we don't have enough material to make the full pipeline connections from the carbon capture, but brass, for example. These were presented at the K Fair also some months ago in China Plast and in the Paris textile lingerie trade fair. Our customer was showcasing the brass made from the captured carbon. We are working on an LCA. It's expected to be ready later this year, but so far the kind of the preliminary figures are showing that the carbon footprint reduction is big. Of course, it's energy-intensive production, so to make an e-naphtha from the captured carbon. So it's really key also what type of energy sources are used. Infinium is operating today. The plant is in Texas, so they operate with the solar energy, and also the scope is to use a renewable energy for this process. Then coming to the bio-based, here, I mean, the typical applications where it started and what is still kind of the major part is packaging, different type of food packaging, where our customers can impact significantly to their carbon footprint by replacing the fossil feedstock with the bio-based. As it's a drop-in solution, it's a food approved, and that's why it's also only option that if you really want to change to more sustainable, and especially in the advancing and demanding applications, to have the equal to virgin quality. One of my colleagues actually presenting in China Plus from Singapore office was making this comparison, which I kind of like, that if traveling between our two offices, we need to really go with the bio-based in order to compensate the flight. Also actually linked to the bio-based, what is not in the slide, but I am happy to share that in June we have actually launched, so one way to also emphasize that we are really committed on the strategy, we have launched some product in some applications that are built-in concept. So instead of having a fossil version of the product, the kind of the standard version of some products in, for example, in the fiber optic applications is having built-in 10% bio content. And this is a kind of clear proof also that the market is unfortunately not ready, but we are, and we want to show that. And that's why we have taken a decision in this kind of application that are a bit targeted to some special type of things, to have the mandatory built-in content to start with something. And this is also one thing where mass balance is a good tool. So we should not be also penalizing that if something is quite simple and doesn't require qualifying, it doesn't mean that it's still not sustainable. It's, the most sustainable thing that we can do is to start. If you have a 10% content, it's not solving everything yet, but it's a start. If you're multiplying with 10%, it's still more than multiplying with 0. Borcycle C is our trademark for chemical recycling. And with chemical recycling, today it's not really bringing a carbon footprint reduction, but it's a key in solving our waste issue. Feedstock types for chemical recycling are really mixed plastic waste, also multi-layer packagings and these things, which in one way there's more and more drivers for the monomaterials, but there will be some food packaging where the key is to really preserve the food. And I mean, that's not, we should not have a packaging that is not doing its job just for having a packaging. So some multi-layer packagings will be needed, and this kind of, for that kind of applications, the chemical recycling is the solution. Also here, it's a virgin level, food contact approved, and purely with the also safety. And some examples where it's been used, the water piping system in Vienna has been also developed, and some parts have been replaced by chemically recycled pipeline connection. And the Eurovision Song Contest drinking cups. A bit of kind of recapping, and I think because I'm plenty of using my time, and maybe I will save also some time for the questions, so I will stop after this slide, but summarizing a bit. So we operate with a mass balance, but it means that really you have the drop-in solution, so especially in a wire and cable application, in healthcare, you are able to avoid the long-term testing times, which is, I mean, sustainability is having a lot of also additional cost in the regulations, etc. The feedstock is more expensive. So if we can skip some unnecessary kind of additional cost, that should be done. And it's not making it any worse in that case. Also to have the safety, the technical requirements that are needed really in the healthcare, and also in the wire and cable, extra high voltage power cables especially. There the drop-in solutions are key, but also allowing to have this built in. So if you can't afford to start with 100%, you can start with smaller. Also, the chain of custody is well covered with ISCC. Also, we work closely with our suppliers, and today we have launched some showcases also to really show and to emphasize that the whole chain needs to be known, but also it's really well monitored here. And the key is that with even it's a mass balance, it's still by taking one truck instead of a fossil from bio-based, you're replacing that amount of fossil materials being used. And that should be the driver that we should also be able to emphasize. Also, it's the unpopular fact, but in Europe we cannot afford to build new plants. We have a lot of assets and we need to utilize those assets. And we cannot afford to put more price tag on the end materials just because like we would be building new plants and skipping the old ones. So sustainability is a key, but we also need to remember that in the long term, sustainability needs to be also economically sustainable. And that's maybe not to stopping is such a negative thing, but basically it's the key is that let's make the bio new normal and let's start with the sustainability and circularity already today.
Okay, we do have time for a quick question if anyone's got anything to ask. I'll ask a question if no one has one. You mentioned, maybe there's an opportunity for carbon capture through if you've got these undersea cables sitting there for 100 years or something. Is any work being done on that space?
Of course, we are in quite many discussions also that basically that also polyolefin materials could be recognized as a carbon storage. So today, some infrastructure, cement, for example, are recognized as a carbon storage. But for example, pipeline connections, wire cables, some of them have much longer lifetime. Even we are talking about just regular film used in buildings as a kind of steam block. We have few customers who are giving a guarantee for such a film of 100 years. So also polyolefin materials should be considered as a carbon storage in certain extent. So maybe not in a single-use plastics, but in some applications. And so that's one element. But maybe a link to the carbon capture, which you mentioned, that's a kind of one interesting type of feedstock, what we see in the future. It's not plenty of available, but if you have an interesting showcase idea, let's talk.
Okay, watch this space. Very good. Well, thank you very much for your presentation. Round of applause, please.